Good morning everybody, and already I have taken 2 classes on group theory, and I have also told you the definition of group. A non-empty set G is said to be a group if it satisfies 4 axioms. The first one is closure axiom, and the second one is associative, third one is existence of identity, and the fourth one is existence of inverse element. And if it satisfies the one more axiom, that is commutative, then the non-empty set is said to be abelian group. Already I have told you, and in my previous video already I have told you the cancellation law and uniqueness of identity, uniqueness of inverse element, and reversal law. Okay, so today I will tell you, if A belongs to G, what is G? G is a group. Okay, if A belongs to G and G is a group, then inverse of A inverse is equal to A. See, very simple, only in one line I will prove it. Already I have told you, if A into B is equal to B into A is equal to E, identity, then A is the inverse of B and B is the inverse of A. Is that clear to you? That means we can write A inverse is equal to B or B inverse is equal to A. Anything you can write. A is the inverse of B as well as B is the inverse of A. Okay, see here. Since G is the group, since G is the group and A belongs to G, so it implies A inverse exists and it is an element of G by definition of inverse axiom. Okay, so A into A inverse is equal to A inverse into A is equal to E. Clear? Now we can say A is the inverse of this one and A inverse is the inverse of A also, we can say. Now it implies A is the inverse of A inverse, that is A is equal to this one. Clear? So we have proved this one. Now let us see. Very interesting problem I am going to tell you. If every element of a group G is its own inverse, then G is abelian. If every element of a group G is its own inverse, that means A is the inverse of A, B is the inverse of B, if A and B belongs to G. If A and B are the elements of G, then according to the given hypothesis, A inverse equal to A and B inverse equal to B. And you have to prove G is abelian. That means G must satisfy the commutative axiom. Because already it is given that G is a group. Only you have to prove it is abelian. That means it must satisfy the commutative law. That means A into B is equal to B into A. Okay. Let us see how interesting the proof is. Only 1 minute I will take to prove it. Let AB belongs to G. So by given hypothesis, A inverse is equal to A and B inverse is equal to B. Clear? Now AB belongs to G, so it implies by closure axiom A into B belongs to G. By closure axiom A into B belongs to G. But if X is an element of G, then X inverse is equal to X. Now AB is the element of G, so therefore inverse of AB must be equal to AB. Is that clear to you? Now every element of a group G is its own inverse. Now since A into B is an element of G, so A into B whole inverse must be equal to A into B. Now apply reversal law. B inverse A inverse is equal to AB. Now what is B inverse? It is B. And what is A inverse? It is A is equal to AB. So this is commutative axiom and hence G is abelian. Clear? Now see another proof. Unless you remember the definitions, you cannot do the proofs. First of all, you should remember the definitions, and that is why while entering the class, I am only telling you the definitions. I am only recalling the definition again and again, so that you can remember the definition very easily, and we can do the proofs also very easily. Clear? So now see here, if G is a group and then the equations XA is equal to B and AY is equal to B, or you may write AX is equal to B and YA is equal to B, will have unique solutions in G, and here given A belongs to G. A is an element of G. Clear? Now AB both belongs to AB belongs to G. Now you have to find out first. You have to find out the solution of this equation, and then you have to prove that that solution belongs to G, and then you have to prove that solution is unique. Three conditions you have to show. First of all, you have to find out the solution which will satisfy the given equation. Second one, that solution must be an element of G. Third one, that solution should be unique. Clear? See here. Given A belongs to G, so automatically A inverse belongs to G. Clear? Since A belongs to G and G is a group, the inverse of A must exist, and that inverse must be an element of G. Now A inverse B belongs to G, so it implies A inverse B also belongs to G by closure axiom. A inverse is an element of G, B is an element of G, so A inverse into B is an element of G. Now given AX is equal to B, now please tell me what should be the value of X so that this equation will satisfy. All of you will tell that the value of X should be B by A. Okay, 100% correct. But my question is that B by A will be equal to B into A inverse or A inverse into B for this equation. Which one is correct? B into A inverse or A inverse into B? Which one you should write? That is the point. So since A is on the left hand side, so you should choose this one, because G is simply a group, not an abelian group. Clear? So if you write this one, so A into A inverse will become E, so E into B is equal to B. But in the second one, since A is on the right hand side, you should choose this one. Is that clear to you? So don't guess, you should see what is the most appropriate answer and what should be the result. Okay, see here. Now A into A inverse B, I am putting X is equal to A inverse B, and let us see what is the value. Then apply associative axiom. You should write here by associative axiom. A inverse A is equal to E by inverse axiom, because by inverse axiom A into A inverse is equal to E. Now by identity axiom, this one equal to B, E into B is equal to B. That means A into A inverse B is equal to B. This is equation 2. So simply compare equation 1 and 2. B is there, A is there. So in place of X, I have written A inverse B. So therefore, X is equal to A inverse B is the solution of AX is equal to B. Clear? And I have already proved that A inverse B is an element of G, and I have shown that A inverse B is the solution of this equation. Now the remaining part is you should prove the uniqueness. Okay, so for uniqueness, let x1 and x2 be two solutions. Clear? So therefore x1 and x2 both must satisfy this equation. Is that clear to you? So that means Ax1 is equal to B and Ax2 is equal to B. Therefore this one equal to B, this one equal to B. So Ax1 is equal to Ax2, and apply the left cancellation law, so that A will cancel out. So x1 is equal to x2. That means both the solutions are same. These two solutions are not different. They are identical. That means the solution is unique. Clear? Now we have to prove the second equation. And for second equation, here I can write B into A inverse belongs to G. It is also closure axiom. A inverse B belongs to G, so B into A inverse also belongs to G. Now, given YA is equal to B. Clear? So in place of Y I am writing B into A inverse. Now B into A inverse into A. Let us find out the value of this expression. So B, then associative, apply the associative axiom. So B into A inverse A, by inverse axiom it is E. Now B into E is equal to B by identity axiom. So therefore B into A inverse whole into A is equal to B. This is equation 2 and this is equation 1. So comparing 1 and 2 we get B is there, A is there. So in place of Y I have written B into A inverse. Clear? So therefore Y is equal to B into A inverse is the solution of YA is equal to B. Clear? Now very interesting thing is that already I have shown that B into A inverse belongs to G, and I have got the solution as B into A inverse. Now you are proving uniqueness. In the same way, let Y1 and Y2 be two solutions. Clear? And since Y1 and Y2 are two solutions of this equation, both must satisfy this equation. Clear? Therefore Y1A is equal to B and Y2A is equal to B. So this one equal to B, this one equal to B. Hence Y1A is equal to Y2A. So by right cancellation law, AA cancel out. So Y1 is equal to Y2. Hence the two solutions are identical. So the solution is unique. Clear? So please remember these two theorems, two problems, and I am trying to give you all the problems very soon. So please try to remember these problems, and I have told you to write it 2 times at least. First remember the definitions, and first check up the problem, and then keep it in your mind, and then try to write at least 2 times, so that you can remember forever. Okay, so thank you for watching my channel, and I am very happy that all of you are watching my classes. So thank you very much. Bye bye.